arc length and curvature of vector value functions. In this video, we are going to what is the length of the path CT, because the speed c prime t is the rate of change of distance traveled with respect to time. The distance traveled by a point moving along curve should be the integral of speed with respect to the time over the interval t0 t1 of time travel time, that is the length of the path, also called its arc length. There is a question as to whether or not this formula actually corresponds to the true arc length. For example, suppose we take a curve in space and glue a string tightly to it, cutting the string so it exactly fits the curve. If we, when we move the string, straighten it out and measure it with a straight edge, we surely should obtain the length of the curve that our formula for arc length agrees, which such a process is classified in the supplement at the end of this section. These are example vector valued functions in R3 3-dimension and the calculation of its arc length and curvature. Curvature of a hemisphere, where G UV equals to R2 U and D is a parameterization of the upper hemisphere of radius R. Show the Gauss curvature at every point is 1 R square and the mean curvature is 1 R. First, we must calculate the following quantities. First of all, from formula 2 in section 7.3 we have, therefore, now a direct calculation shows that, furthermore, therefore, and this is the last calculation, that equals to 1 W R R Q D equals to 1 to R. These are two other applications of vector valued function. First is Newton's second law. If a particle of mass m moves in R3, the force of F acting on it at the point ET, CT is related to the acceleration AT by the Newton's second law. FCT equal to MAT. Circular orbits. Consider a particle of mass m moving at constant speed s in a circular path of radius r0. Supposing that it moves in the xy plane, we can subtract the third component and write its location as this. I will conclude my presentation, and this is my reference. Martin J.E. and Tomba A. 2012 Factor Calculus WH Freeman. Thank you.